Hello everyone, welcome to my channel. My name is Johannes. So I'm going to solve some problems on kinematics of particles as part 1, which includes rectilinear motion of a particle, and also we will have some uh, exercises on this topic. Now let's see. Now let us see the detail. So before I go to the detail of kinematics of particles, now let me speak a few points on learning objectives. By the end of this chapter, students will be able to describe the basic kinematic relationships between position, velocity, and acceleration in the time, and also you will be able to study particle motion along a straight line and represent this motion graphically. So we will see acceleration versus time curve and distance versus time curve from velocity time curve. And you will distinguish how to draw velocity time, acceleration time, and distance time graphs. And you will be able to locate any relevant points or corner points or coordinates from the velocity time curve or distance time graphs to formulate equations as equations. So let us see. As introduction, what is dynamics? Dynamics is concerned with bodies that have accelerated motion. So if you have something in motion, then it will be dynamics. And kinematics is the study of the geometry of motion. The geometry of motion, study of the geometry of motion, and kinetics is the study of forces that cause the motion. And rectilinear kinematics refers to a straight line motion, whereas curvilinear kinematics just describes a body in motion with just a curved path. And speed refers to the magnitude of the velocity, and average speed is the total distance traveled by total time. So total distance by total time will give you average speed. This is different from average velocity, so which is just the displacement divided by the time, if it is average velocity. But average speed is simply total distance divided by total time. And a particle that is slowing down is decelerating. Otherwise, if a particle is just increasing or moving, then it will be accelerating, or if it is increasing its speed. So a particle can have an acceleration and yet have zero velocity sometimes. Respect to time, and velocity is the rate at which the rate of distance with respect to time. So just from here, if you calculate dt, then you will find this equation, which is important. We will see the detail in example problems. So first, we have to know equations of motion. For constant acceleration, this has equations of motion. So the first one is velocity, which is final velocity is equal to initial velocity plus acceleration times time, and distance delta x, which is moving, final velocity plus initial velocity over 2 times t, time, which is average velocity, or sometimes delta x, or the change in position, will be v naught t plus half a t square, and again final velocity square is equal to v initial square plus 2a change in position. So you may describe this x final minus x initial. Then finally you can make, for example, s here. S is equal to s naught, which is initial position, then plus this one you can make. So you have such distance, velocity, and distance, and also similar equations. So these are for constant acceleration. We may use for rectilinear motion. So basic concepts on velocity and acceleration. Let me speak a few points on velocity and acceleration. So the average velocity of a particle during the time interval delta t is nothing, the displacement divided by the time interval. So you may have time interval between t2 or t final and t initial, then you have to make delta t. So average velocity is nothing, the change in displacement divided by change in time. And As delta t becomes smaller and approaches to zero in the limit, the average velocity approaches to the instantaneous velocity of a particle, which is given by b is equal to limit, just as delta t approaches to zero, which is del s divided by del t, or you can make b ds or divided by dt, which is s dot, which is the rate, just the distance, the rate of distance with respect to time. Or sometimes you can make derivative or just the slope or the gradient of this distance equation will give you the velocity at that time. So nothing, the velocity, which is the rate of change of position or coordinate or s. And the average acceleration of a particle during a time interval delta t is the change in its velocity divided by time interval. Similar, you have to keep this formula again. You have to keep this one. This is average acceleration. And as delta t becomes smaller and approaches to zero in the limit, the average acceleration approaches to the instantaneous acceleration of the particle, which is just if you make limit, then you can have average acceleration. So just as delta t approaches to zero, then we will have this equation. Acceleration is the change in velocity by change in time, or the rate of change of velocity with respect to time, v dot, or else if you substitute here ds by dt, then it will be this one. So acceleration is the second derivative of distance equation. So if you have distance equation, you can make this one, s double dot. So by eliminating the time delta t in both equations, then after rearranging, you will obtain the differential equation relating the displacement, velocity, acceleration, which is v dv is equal to a ds, or you can substitute v means s dot, or just ds by dt, which is this one, dv means ds. Again, you can make acceleration is s double dot, and you can have this equation. So problems in rectilinear motion involving finite changes in the motion of variables are solved by integration of these basic differential equations. So as a note, the positive directions for v and a are the same as the positive direction of s. Clear? So let us see now uniformly accelerated rectilinear motion. If acceleration is constant already, you have dv by dt. Then if you just crisscross this one, then it will give you integral of dv. This is just crisscross. Make crisscross, then integral v naught up to v dv is equal to acceleration from 0 to t dt, where a is constant, so you will have just this equation. Similarly, this one, dx by dt, you can substitute now, which is velocity, in terms of velocity, v naught plus at, then you will find this equation. So we are just deriving the rectilinear motion equation for constant acceleration, and you have again v dv by dx is equal to a, which is acceleration constant. Then if you integrate, if you crisscross this one, v dv is equal to a dx, then it will give you this equation. This is the third equation of motion. Then careful attention must be given to these equations. These are applied only for uniformly accelerated rectilinear motion in a straight path. A common mistake is to use these equations for problems involving variable acceleration, where they do not apply. So if you have variable acceleration, you cannot apply this equation. These equations are applied only for uniformly accelerated motion, linear motion. So second, velocity given as a function of time. If you are given velocity as a function of time, then velocity is nothing, ds by dt, the derivative of distance divided by dt. Then if you crisscross, then integral s naught from initial up to s ds is equal to integral from 0 up to t v dt. Then after rearranging, s will be s minus s naught here. This is 1. Then after integrating, you will get s. Then this will be this equation. So if you are given velocity versus velocity as a function of time, you can use this equation to calculate S. Acceleration given as a function of time. Again, if you are given acceleration as a function of time, you simply just have dv by dt, then you can just crisscross this one. Crisscross, then acceleration function you have, then velocity can be obtained. Clear? The velocity can be obtained using this equation. And if acceleration given as a function of velocity, then acceleration is a function of velocity, which is acceleration being dv by dt. Then if you just crisscross this one, you can have t. T will be integral of this one, integral both sides. Then you will have f of v, which is acceleration as a function of velocity. If you are given, then you can find if t as a function of velocity can be obtained. Another approach to just to substitute the function a is equal to f of v, which is, you can have this one, v dv is equal to a ds. Then v dv is equal to f of v. Instead of acceleration, you can substitute f of v. Then you can have integral both sides. Then you have ds over fv from v naught up to v. F of v you can substitute. Then you can integrate s naught up to s. Then you have this equation to compute the distance, where f of v is acceleration function in terms of v. So note that this equation gives s in terms of v without explicit reference to time t. And acceleration given as a function of displacement sometimes may be given. So you will use this equation. Again, you bring this equation, v dv is equal to just a ds. Then if a is in terms of f of s, you can substitute f of s. So integrate both sides, then you can have, this is the velocity. The velocity you can find. If acceleration in terms of displacement is given, you can calculate the velocity final. We can solve for velocity v to give v, which is g of s as a function of s. Now we can substitute ds by dt for v, which is v is the rate of change of velocity, change of distance, separate variable and integrate. Then finally you can have t. T as a function of s can be obtained. Then finally you can calculate time. So graphical interpretation, you have this graphical interpretation. If you are given s versus t, then you have this velocity, which is distance curve. So if you have distance curve, then if you derivate the slope of this distance curve at any point, or the tangent point which is given, the slope of this one will give you the velocity at that point, the velocity at t. Similarly, if you are given velocity versus time curve, then dv by dt, or the derivative of this function, this is velocity function, this is distance s of t, this is s of t, there, s of t, and this is v of t. Then if you derivate this function, automatically it will give you the acceleration, which is the gradient or the slope of the velocity function at any point will give you the acceleration at that point. Then, or the area under the velocity time curve will give you the distance traveled by body. So integral s1 up to s2 ds, integral from t1 up to t2 v dt will give you area under the curve, which is between s2 and s1. So this is the distance traveled. So if you are given acceleration versus time again, you can just have similar approach, integral just dv, then you have integral a dt, then the area under at curve will give you the velocity of a body for a particular interval. And again, if you have acceleration versus as, v dv is equal to a ds, then the area under as curve will give you this one, which is important, which is acceleration versus s curve. Then sometimes you may have erratic motion which is changing in motion. For every interval, here at point t1, you may have v1, which is s versus t. If you are given, then you will have erratic motion, which is the rate at which the distance is changing with respect to time. Here different, here again different, v1, v2, v3, different. So this is erratic motion, changing in motion. And if you have velocity versus x distance, or velocity versus s, then you can just calculate dv by dx, which is the slope of a line tangent to this point, will give you dv by dx. Then finally, you have acceleration. Acceleration will be this one. Acceleration will be this one. V dv by dx. If you are given velocity as a function of x horizontal, then you can calculate a will be just v dv by dx. Simple. And sometimes you may have distance versus time curve. Then the slope of this tangent line will give you the velocity as a conclusion. And if you have velocity versus time curve, then the slope of this, or the derivative of the function, will give you the acceleration. So this acceleration will be acceleration curve at this point you can find. So given xt curve, the velocity time curve is equal to the xt curve of slope. Here, the xt of slope curve. And given the velocity time curve, the acceleration t curve is equal to the velocity t curve slope. The velocity t curve slope. So vice versa, you can just have these equations and this curve interpretation. Very important in calculations. Okay, in summary, just if you are given function, for example, v of t, if you are given, to find the velocity, you simply, at any time t, you can substitute t. To find acceleration, you simply derivate the velocity function dv by dt. To find s of t, you simply just crisscross this one, then integrate v dt, because v is nothing, v is ds over dt. ds over dt. So s will be, if you just crisscross, then s will be integrate v dt. And solve for t for a given v or a to find the time. And s of t, if you have s of t function, then to find the velocity, you simply just derivate ds by dt, and the acceleration will be dv by dt. So once you have v function, again you derivate, or just double derivative of s. Then substitute t value and solve for t again. If you are given acceleration as a function of time, velocity will be integral of a of dt, and substitute t value, then plot the curve, and then solve for t for any given velocity and acceleration. And if acceleration, these are just something special equations. If acceleration as a function of distance is given, a of s or a of x, then v dv is equal to a dx. You will use this one. Then from this, integrate both sides, and then finally you can find velocity here. For integration, you can find velocity function. Then finally, at any interval, it will be solved. Then similarly, to find a of t, you can have here. Then once you have a of t, then finally you can substitute the variables and the known and integrate. If s of t is given, then if s of t is unknown, integrate and then plot the graphs and solve for t for any given velocity or distance s. You can calculate. And if acceleration is equal to as a function of velocity, then you can use this equation, which is a of v, which is dv by dt. Then finally, you can go to this equation, v dv over dx is equal to a of v to find the acceleration. Then you substitute the time and the velocity. Then finally, you will use this equation to find s of t, integrate dx, then finally you can have this equation. So these are summary table for calculation. So as a remark, concluding remarks, we have these concluding remarks we have to keep in mind for every calculations and also graphs. Straight lines on distance time graph represent constant speed. Constant speed. So you may have such curves, for example, distance versus t, then constant speed. Straight line. It could be like this. Then it could be like this. So this is constant speed. The steeper the gradient, the faster the object is traveling. This is also another approach. And horizontal lines on velocity time graph represent constant speed. So if this is just on velocity time curve, if you have velocity and time curve, velocity time curve, then you have, if horizontal given, if this velocity is horizontal, what does it mean? Constant speed and zero acceleration. And vertical lines on velocity time graph would represent an infinite acceleration or impossible if it is vertical like this. Infinite acceleration, which is impossible in velocity time graph. And also horizontal lines on distance time graph represent stationary, which is just at rest. And vertical lines on distance time graph would represent an infinite speed. On distance time graph, if it is vertical, then it is an infinite speed, which is impossible. On a position, just velocity time graph, the y value represents the position and the slope represents the velocity. Clear? Because just if you have a position, distance versus t, then if you have ds by dt, it will give you velocity. On a velocity versus time graph, the y value represents the velocity and the slope represents acceleration, because dv by dt will give you acceleration. The area under the curve represents the displacement. On an acceleration versus time graph, the y value represents the acceleration. The area under the curve, regardless of the shape of the curve, it will represent the change in velocity during the time interval. So these are the concluding remarks. Now let's see examples.
Okay, now let us see example 2.1, rectilinear motion. S as a function of time, a particle moves along a straight line such that its position is defined by S is equal to t cube minus 3t square plus 4t in meter. Determine the position, the velocity, and the acceleration of the particle when t is equal to 6 seconds. This is one question. And the displacement and the average velocity of the particle during the time interval from t 2 seconds up to t 6 seconds. Now let us see the solution. First, solution at t 6 seconds, you can substitute s of 6. S of 6 means you substitute in the equation, which is s as a function of time. Now you can substitute 6 cube minus 3 times 6 square plus 4 times 6, then you get 132 meter. Then next step, you can have velocity, which is ds by dt, derivative of distance by dt. So if you derivate this equation, then which is 3t square minus 6t, 2 times 3 plus 4. Then v of 6, you can substitute now 40 meter per second. Then acceleration will be dv by dt, the rate at which the velocity is changing with respect to time. So 6t, again you substitute this velocity, 6t minus 6. So a of 6 will be 30 meter per second square. So please keep in mind these equations. So the velocity is the change in s by dt, or the rate at which the distance is changing with respect to time. So if you just make crisscross this one, then integrate ds from 0 up to s is equal to integrate v dt from 0 to t. And if you have acceleration, which is the rate at which the velocity is changing with respect to time, so you have this one, this cross, then integration dv from 0 to v, integrate from 0 to t, a dt. So just you have function of, if acceleration is given as a function of time, you can integrate here. If velocity as a function of time is given, then you can integrate. So please keep in mind this equation, basic equations. So this is the distance time graph. So you can have for every second you can plot 0, 1 up to 6. You have at 6 you can get, which is the distance 132 meter. So at 6 will be 132 meter. Again, the velocity time graph will be v is equal to 3t squared minus 6t plus 4. So this is the velocity time graph. Then this is acceleration time graph. So acceleration is 6t minus 6. So at t6 you have 6 times 6, 36 minus 6 will be 30 meter per second square. So this is acceleration time graph. Then the displacement is found from at t 1 second, at t 2 second, at t 2 second. You can simply substitute s of 2, then 4 meter. At t 6 second, you have s of 6, 6 cube minus this one, you have this one. So the displacement is nothing, is change in s or delta s between 2 second to 6 second. So s of 6 minus s of 2, this is the displacement of the particle. Then the average velocity is found from the change in displacement divided by change in time. So change in displacement is already 128. Then if you divide by 6 minus 2, then you get 32 meter per second. So this is the average velocity. So as exercise, we can try this problem. The velocity of a particle is given by v, which is 25t squared minus 80t minus 2000, where v is in feet per second and t is in second. Then plot the velocity v and acceleration a versus time for the first 6 seconds of the motion and evaluate the velocity when acceleration is 0. So you are given a v of t, then you can find a of t and also s of t, etc. Then you can plot.
0. Okay, second problem is rectilinear motion. If this distance is given by x of t, which is this one. If distance is given by a function of time, determine the position, the velocity, the acceleration of a particle when t is equal to 2 seconds and 4 seconds. And sketch the graphs for every second. Now let us see. So at t 2 seconds, you simply substitute x of 2. You get 16 meter. And at t 4 seconds, it will be x of 4. Just you substitute in this equation. It is a function, which is distance equation. And then finally, you have this one, 32 meter. And to find the velocity, which is the derivative of distance, dx by dt, it will be 2 times 6, 12t, minus 3t squared. Then what will be the velocity at 2 seconds? V of 2. You substitute 12 meter per second, V of 4, 0 meter per second. Then acceleration dv by dt, 12 minus 60. Acceleration again, you derive again this one. So 12 minus 60, then what is a of 2? 0. And a of 4, you get this one. You simply substitute in this equation. And to plot the graphs of the position, the velocity, acceleration of a particle, we shall prepare a tabular data for every second. For every second means 1 second interval. So you have t versus x or distance. From 0, you start from 0. Then 1, 2, 3, 4, 5, 6. Then you get the values at t, for example, at t 4 second, we get 32. At t6 second, what will be? 0. Then it goes on like that. This is tabular data. And t versus v, again, you have equation, which is the velocity function, which is this one. You bring here, you substitute, then you get these values, velocity. And the third tabular data is acceleration, which is 12 minus 60, this equation. So we are using three equations. Then we can develop curves. So velocity time curve for every second will be like this. This is the velocity time graph. And this is the distance versus time graph, which is this one. And the acceleration versus time curve will be this one. Then if you calculate at t 2 seconds, what will be the acceleration and the velocity? We have computed velocity 12 and acceleration 0. Again, at 4 seconds, we have velocity 0, you see, and acceleration 12. Negative 12, negative 12. And similarly, distance versus time, if you calculate at 4, it will be distance 32 meters. So let us see now rectilinear motion. If velocity as a function of time is given, then what will happen? The velocity of a particle which moves along the s-axis is given by this one. Along this axis, which is along the x-axis, will be this one. Then where t is in second and v is in meter per second, evaluate the position s, velocity and acceleration when t 3 seconds. The particle is at the position s0 3. Initially, it will have x0 will be 3 meters when t 0. So you will consider this position. So at t0, s0 will be 0. This is given initial condition. Then you bring the velocity, which is equation ds by dt. Then finally you have the equation, which is this one, which is the velocity function is given 2 minus 4t plus 5t to the power of 3 over 2. Then acceleration you can find. Acceleration is dv by dt. So if you derivate this function, if you derivate this function with respect to time, it will give you negative 4 plus 5, 3 over 2 you bring here, then 3 over 2 minus 1, then this will be the equations. So velocity function and acceleration function. Then you can find the position. So you simply just crisscross, then integrate ds from s0 up to s is equal to integral, which is v, this is v dt. So if you integrate, it will give you like this. So s minus s0. So s0 is already known, 3 meters. Then the position will be computed. So the position will be, you bring s0 to this direction. Then finally, at 3 seconds, then what will be the position? 22.177 meters. And the velocity will be, v of 3 will be 15.981. And acceleration will be a of 3. This is acceleration function. A of 3 will be this one. So position, velocity, acceleration already computed. So having this, you can go to the other. So a particle, which is, if acceleration as a function of s is given, how do you calculate? A particle travels along a straight line with an acceleration of this one, where s is measured in meter. Determine the velocity of the particle when s 10 meter, if v 5 meter per second at s is equal to 0. So when the distance is at 0, which is at the initial point, the velocity was 5. So what will be the velocity of the particle? So given a as a function of s 10, s0 0, so v0 will be 5. This is the initial condition. So s0 0 from v dv is equal to a ds. You simply substitute integral from v0 up to v dv, integral from s0 up to s, f of s, which is acceleration as a function of s. Then here will be v square minus v0 square from here. Then finally you have just plus, because this is v square over 2. After integration, this will come out v square over 2. So if you substitute v and v naught, it will give you like this. Then if you multiply these two to the other side, it will give you like this. So this is the equation to compute the final velocity. So final velocity will be v square, which is this one. So initial velocity already given 5 square plus 2 times f of s you have here 10 minus 0.2 s. So since it is in terms of s, you can integrate. So after integration, you have 10 times s. This is 10 constant. Then 0.2 s square over 2 from 0 up to 10. From 0 up to 10. When s 10, s not 0. Then after integration, if you substitute, it will be like this. Then after square root, you have this is the velocity when s is 10 meters. When s is 10 meters. Okay. Other problem is velocity as a function of s, similar with above, but the question is acceleration. So a particle travels along a straight line with a velocity v 20 minus 0.05 s square meter per second, where s is in meter, determines the acceleration of the particle at s 15 meter. So let us see, given that v as a function of s, so s 15 meter from v dv is equal to a dvs, you can find a. A is v dv divided by ds. Just after rearranging acceleration, you can find. So you simply substitute v and again derivate. Clear? You have acceleration equation, and then if you derivate dv by ds, you substitute here, then you get this equation. Then at s 15 meter, which is a of 15, you have this one. So this shows deceleration. So this is the acceleration of a particle at s 15 meter. So as exercise, you can find this one. The acceleration of a rocket traveling upward is given by this equation, acceleration as a function of s, where s is in meter, determine the time needed for the rocket to reach an altitude of 100 meters. Initially, v is equal to 0. So initially, v is equal to 0, s is equal to 0, when t is equal to 0. So this is just the time required. You are asked, you can find. Okay, example 2.6, rectilinear motion, velocity time graph, acceleration time graph, and distance time graph. So a motorcycle starts from rest at s0 and travels along a straight road with the speed shown by the velocity time graph here. This is the velocity time graph with the equations given. You have equations. Determine the motorcycle's acceleration and position when t 8 seconds here. 8 means around here and 12 means around here. Here, around here or around here. And plot acceleration versus time and s versus time curve. Then you have equation from 0 up to 4. You have equation. This is the velocity equation. Velocity versus time curve given. Then velocity constant here. This is the velocity is constant, and here the velocity is just like this, negative t plus 15. So how do you get these equations if you are not given? You have to make these coordinates. Once you have coordinate 4, 5, here 0, 0, then you can have equation of a straight line. If it is straight line, you will use equation of straight line. And if it is constant, then v is equal to 5. Simply y-axis. And if this one, you have two coordinates, this coordinate, then you can just develop equation of this kind. Let us see. At t 8 seconds, acceleration is equal to dv by dt. So acceleration at 8 will be 0 because velocity is constant. If velocity in velocity time curve, if the horizontal line is given, then acceleration will be 0. No acceleration, it is constant. dv by dt you don't have. Then similarly, from v is equal to ds by dt, it just crisscross this one. ds is equal to v dt. Then you have velocity function. We simply substitute. So integral from 0 to s ds is equal to integral v dt from this equation. Then s minus s naught is equal to integral, first different equations, here another equation, here another equation. So you have to use both equations. So from 0 to 4 v dt, this function, you have to use this function. And from 4 to 8, from 4 to 8, you have to use this equation. So two equations, 1.25 for 0 to 4, and for v dt, from 4 to 8, you have 5 dt, because this is 5 function velocity. Then after integration, you have this one plus 5t from 0 to 4, from 4 to 8. So you will have distance. So total distance, the position will be 30 meters. 30 meters. At 8 seconds will be 30 meters. Hence, at the 8 seconds, S will be 30 meters. Then, total area covered up to 8 seconds equals to total distance covered from 0 to 8 seconds. So, summation of this area 1 plus area 2. So, triangle plus rectangle up to 8. So, half of 4 times 5, this is triangle. Then rectangle, 8 minus 4 times 5. So, it will be 30 meters. Area covered by this region. So, at 8, you have A1 and A2. Then, at t12 seconds, we have 3 velocity equations, because 12 is around here. So, first, let us determine acceleration. We have to determine acceleration. So, acceleration will be A is equal to dv by dt. So, v2 minus this one, v1, t2 minus t1. So, you have here 0. Then, you have 0 minus 5, 0 minus 5, then 15 minus 2. This is just, you can have this one, 0 minus 5 divided by 5 minus vertical increment over horizontal distance. So you have negative 1. So you can see the slope. You see, dv by dt is acceleration at this location from 0 to 15, dv by dt. Then you simply use this one, integral ds from 0 to s, integral v dt from 0 to t, s minus s naught, then integral from 0 to 4 first, from 0 to 4, you see, then from 4 to 10, from 4 to 10 constant speed, you have 0 acceleration, and then from 12, 10, here you have 12. 12 is around here. 12 is around here. So you have from 10 to 12 v dt. So these v functions, you have 3 equations of velocity as a function of time. So you will substitute these equations, then finally integrate for the given intervals. Then finally, you can just calculate total distance. Total distance first, you have 48 meters. 48 meter total distance up to this point. Total distance, total position, and you can plot now acceleration versus time and distance versus time graphs. So you have for t less than 4 seconds, up to 4 seconds, you have velocity. dv by dt, you get this one. So this is the acceleration value. Then integral ds, integral v dt, just you have v is equal to ds by dt. So just crisscross this one, then integrate both sides. Integral ds from 0 to s, 0 to t, 1.25 dt. For this interval, you can find s. Then s will be this equation. So if you have s equation, you can develop a curve. So when t 4 seconds, 10 meters. Then for 4 up to 10, from 4 up to 10, you have velocity function, dv by dt, acceleration is 0, Then you have similarly just integral ds from 10 to s, from 10 to s, you have from 10 to s, then you have 4 to t, 5 dt, then you have 5t minus 10, because this is a boundary. Then you have again just as a function what will be when approaching from this one. So you have this equation, then when t is equal to 10 seconds, s of 10 will be 40 meter. 40 meter, you simply substitute in this equation. So this equation is nothing, s minus 10, you have here, s minus 10 is equal to, then integrate this one, 5t, then the interval will be from 4 to t, from 4 to t. So you simply substitute instead of t, t minus 4. Then it will be 20, then after rearranging, you get this equation here. So this is just the integration. How do you integrate? T, 5t in bracket minus 4. Then finally, after multiplication, it will be minus 20 plus 10, then it will be minus 10. Then for t from 10 up to 15, from 10 up to 15, from 10 up to 15, again, you simply take dv by dt, which is acceleration. dv by dt will be -1, already known. Acceleration is known. Then integral from 40 to s. Integral from 40 to s, already s is 40 at 10. 40 you have from 40 to s. Anyways, because this is not this is velocity curve, so you have to take from 40 up to s. Then what will be? So you just substitute the equation, then integrate, then finally you have negative t squared over 2, 15t. Then from 10 to t, after substitution, you get this equation. Then finally, when t 15 seconds, s will be 52.5 meter. So once you have this equation, then you can plot the curve. Then to plot the curve, acceleration versus t, we have equation. From t, from 0 up to 4, you have 1.5 acceleration. So you simply make constant acceleration. Constant acceleration. Then you have 1.25. Again, just at 4 seconds. Then you can substitute for here. Then from 4 to 10, from 4 to 10, acceleration is 0. 0 means just on the horizontal axis here. Then from 10 up to 15, you have -1. So you simply put -1. So this is the region of acceleration versus time curve. And distance curve, you simply put the values. From 0 up to 4, you have here distance 0. Then if you substitute here, it is concave upward, then it is parabola like this. Then you have straight line with slope 5. It goes on 40. At 10, 40, already calculated. At 15, you have 52. So you have 52 here. So this is concave down. So this is acceleration and distance curves. So I think this is as exercise you can try. The velocity time graph for a train in a straight path is shown below. For the data shown, you have data from this coordinate system, t versus p. Then you can have to construct distance versus t and acceleration versus t graphs for the motion from 0 up to 180 seconds. So you have to develop equation of these lines equation, then you follow the same approach. When t0, s will be 0. So if you follow the same approach in the above, you can try. So as exercise 2, you have a motorcycle is moving with an initial velocity of 8.5 meters per second at time t0. The roadway causes the motorcycle to accelerate over a time as shown on the graph below. What is the motorcycle's velocity at t 9 seconds? So you are given acceleration versus t. So please try to calculate the acceleration equation. A of t you can develop from this straight line. So put the corner points here, the coordinates at this point and at this point, then find the equation of acceleration. Then finally, you will follow the same approach. So you have initial velocity, then what will be the velocity at t 9 seconds. So this is the question. So I hope everything will be clear. So these are main illustrative examples on kinematics of particles for rectilinear motion with graphs and also equations. So I hope I will proceed part 2 with curvilinear and relative motion of particles. So if you have any question, you are welcome. Thank you. Okay, so this is all about today's tutorial. Hopefully you liked the video. If you have any comment or doubt regarding this topic, please let me know and write down in the comment section. Thanks for watching.